Newton's first law of motion was a new way of thinking about how things moved. Because in the 300 BCs, Aristotle noticed that to get an object moving from rest, you had to put a force on it. And when that force was removed, the object came to rest. So the idea became that all objects tended to come to rest unless a force is acted on it. Newton's first law of motion says that every body persists in its state of rest or state of moving in a constant speed and a constant direction, except to the extent that it is compelled to change that speed or direction by an outside force. So if you have an object at rest, it's going to stay at rest until something acts on it. If you have an object in motion, it's going to keep the speed and the direction that it's going unless something acts on it. So if we look at moving a box across a table, right? You initially put a force on it, you get it moving, and then it slowly comes to a stop, or quickly comes to a stop, depending on how smooth your table is. Right? Does that violate this Newton's first law? No, and I'll walk you through how. This is a pretty heavy box here. We can see after the push that it stopped at 18 inches. Once my hand was off the box, there still were forces acting on the box though. You have gravity pulling down, you have the table pushing up, but those are the same size, so they cancel each other out. They don't affect the motion of the box. So what else is causing the box to slow down? Now, this table is fairly rough, so what if we moved it to a slightly smoother table? Same box here. And same push. And we can see that the box went to 26 inches here. That's 7 inches farther than when the box was on the rougher surface. Now imagine if we kept getting a smoother and smoother and smoother table. The distance it would go would be longer and longer. So if you had an infinitely smooth table, the box would just keep going and going and going and going. So that means there must be another interaction between the table and the box that's actually stopping the box from moving. And that's what we call friction. And there's static and there's kinetic friction. But as it's moving, it has kinetic friction slowing it down until it comes to a stop. And that's the force that we don't see that's causing the box to come to a stop. Now, the unofficial statement of Newton's first law says objects in motion tend to stay in motion, and objects at rest tend to stay at rest unless they're acted on by an outside force. So I've got a question for you. Is a change in position an indicator of a force having been acted on an object? Feel free to pause the video if you need to while you think about it. Alright, so if it's just a change in position and the object was already moving, then it doesn't necessarily mean that there was an interaction. It could have already been moving, and if you saw it while it was moving and then noticed it in a different spot, still moving with the same speed and direction, that doesn't mean that there was any interaction. But if you had a box that's at rest in one spot and later you notice it at rest in another spot, then you know that there was an interaction. A force had to have acted on it to get it to change position and stop again. I'm Ben, this is Physics or Bust, and remember to hit the like and subscribe, and remember, keep asking questions. See you on the next video.